Woohoo! Was that the opening remarks on this? Woohoo! Statistics. Okay. So when I want to describe some numbers that I've gathered, I might want to describe the middle-ish number. So that middle, that balance number might be the mean, which is the number we usually call the average, although all of these measures of center could be called the average. And that is the sum of all the values divided by the size of the data set. Oh, okay, I remember how to find a mean. 0 plus 5 plus 3 plus 12 plus 8 plus 10 divided by 6. Okay. Ari didn't find what he was looking for. He left. Okay. So and what is that mean? I'm sorry, what is that? 6 1/3, okay? So I say the x with a bar over the top, called x bar, that's an abbreviation for mean of a sample, is 6 1/3. Okay? So the center of this data set is about 6 1/3. The average number is 6 1/3. Okay. Median. Center of a data set. Okay, so to find the center, I'll put all the numbers in order. 0, 3, 5, 8, 10, 12, and I'll find the number smack dab in the middle. Oh, well, the number smack dab in the middle is isn't a number in my data set. So I take the mean of the two numbers around the center and add 5 plus 8 and divide it by 2, and I get 6.5. So the median mostly people write median, or they write MED, is 6.5. Sometimes I will find it better to describe my data with the median than the mean. Sometimes they'll be close enough that it won't really matter which measure I use to describe them. Yeah, you know, if they are about the same, my measurement of choice is the mean. If they aren't the same, often my measurement of choice is going to be the median. I'd go ahead and use the mean. We'll look at graphs of the data to decide whether we're going to use the median or the mean. But when they're about the same, the mean is the better choice because of a certain branch of statistics called parametric statistics, which uses the means, which is a little more developed than the branch of statistics called non-parametrics, which uses the median. Okay, onward. I can also describe these numbers, besides where their center is, I can describe how varied my data is, how much variety I have in my data, how approximately the distance, approximately the distance each one of these numbers is from the mean. Okay? And it'll tell me whether my numbers are really spread out from the mean or all really tightly clustered together. Is it negative? I don't see a -2 at all. Oh, yeah, that's an X bar. Okay. Well, all right. So this number is that one of the numbers of describing the spread is called the standard deviation. It is abbreviated either as an S or a Greek letter sigma. And it is take each one of the numbers, subtract the mean, and we'll just use 6.3, square that, sum that with the next number, square that, and the next number, and the next number, yeah, the 6.3, wasn't that the mean we got a minute ago? And the 8, and the 10. There is, but I show you this formula because on your STAR test, they'll ask you to calculate a standard deviation by hand because you don't have a calculator to use. Yeah. They'll only do about 4 numbers, but it's ridiculously hard to do. But anyway. Do they give you what? No. Yeah, this is one question on the STAR exam that does that. If you remember the formula, you might get it right. All right, and then I got to divide by the number of numbers in my set, 1, 2, 3, 4, 5, 6, minus 1, 5. Then I got to take the square root of all that. That's the crazy part, but sometimes you can kind of estimate it and get the right answer. Yeah, it's like I said, it's crazy. All right, so 0 minus 6.3 squared is 39.7. 5 minus 6.3, all of that squared, is 1.69. You don't get which part? Oh, sorry. I had to write all that in one line. Then we divide by the number of numbers we have, which is 6 minus 1. Yes. Why is it divided by 5 as opposed to 6? Well, there's a really good explanation of this, but it goes fairly deep into statistics. Let me give you this explanation, that this standard deviation is for a small sample of data that's collected out of a large population of data. And because it's a small sample, it's not big enough to get a good standard deviation that would be a reasonable estimate for the standard deviation of the population. So to correct for the fact that it's too small, we divide by 1 less. Okay? So that's actually a proper... Yeah. 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 Ah, 32.5. And you're not doing this, I can tell. You're just like going, what is she talking about? 2.89, and last one. Square of that one is 13.69. I still got to take the square root of that after dividing that whole thing by 5. We're going here. All right, I got 39.7 plus 1.69 plus 10.89 plus 32.5